All right, in the previous video, we went over how to introduce all this notation carefully, the sets, the inputs, and decision variables. Now we're going to utilize all this notation to write down the mathematical formulation the lazy way, I call it, because instead of writing, a number of terms, like in this case, we would have 2 plants and 3 warehouses, and we're going to have lots of terms in the objective function. We're just going to get away with writing a few letters and some symbols. How to do that? Well, let's break it down. First, let's go back and look at our problem instance. So if you were to calculate, if you were asked, what's the cost of shipping 100 tons from Colorado to Ohio? Can you compute it? That's pretty straightforward, right? How much does it cost to ship 100 tons from Colorado to Ohio? So that refers to the decision variable xij is the 100 tons being shipped, right? That's what it's saying. If our x sub 1 referring to Colorado, 3 referring to Ohio, if our x sub 1 is 100 tons, what would be the cost? Well, for that, all you need to be given is the unit shipment cost. How much does it cost to ship a single ton of the product from Colorado to Ohio, right? So this was given in the cost matrix, right? The cost to ship from Colorado to Ohio was given as $1,331 per ton. We refer to this unit shipment cost, we abbreviated it using C sub 13, but this notation effectively refers to this unit cost, 1,331. Well, that's for just 1 ton. If we're told we're shipping 100 tons between Colorado and Ohio, then multiply this cost with 100, we'll get the cost of shipping 100 tons from Colorado to Ohio. $1,331 per ton times 100 tons. That'll give us the cost. That'll give us just the cost between this pair, right? This Colorado-Ohio pair, this origin and destination pair. And if we wanted to write this the lazy way, not write 1331 times 100 ton, we just refer to this as C, the unit shipment cost, from Colorado is index 1, Ohio index 3, times 100 tons was given in this slide for illustration purposes. We, of course, don't know what the optimal amount to ship between Colorado to Ohio yet, right? So we represent that unknown with our decision variable x, which is the amount being shipped from Colorado to Ohio. So this is how we would compute the cost of shipping in general, X amount from Colorado to Ohio. Okay, so if this is the cost of shipping X amount from Colorado to Ohio, and we express it using this notation, what would be the total cost of a shipment strategy? So you come up with some strategy, you allocated the demands from the warehouses to the supplies. Now you have to calculate the total cost of all the shipments that you're sending from the plants to the warehouses. Well, then you're going to have to repeat this for every single origin and destination pair, for every IJ, right? So the unit shipment cost from origin 1, Colorado, to destination 1, which is California, multiply that with the amount being shipped between this origin and destination. But that's just one pair, that's Colorado and California. But you're going to have to repeat this for all 6 from Colorado, right? This is still 1, Colorado, the origin. Then the second destination, Texas, and the amount, plus the unit shipment cost still from Colorado. We're still dealing with the Colorado plant, but now to the third destination, Ohio, multiply that with the amount being shipped. So we have just written the shipments out of Colorado. Now moving on to the shipments coming out of South Carolina to the 3 destinations. So now this first index switches to 2 because that's South Carolina. And now we're simply iterating over the destinations. First 1, 2, and then 3. This was effectively what we did was the matrix multiplication. So if you don't recall, maybe you want to go back and watch the video on matrix multiplication. We have the cost matrix, CIJs, and we have the decision variable matrix, XIJ, and we simply took the product of the elements in these tables and added them up. And that was our, what we refer to as matrix multiplication. And that's our total cost that we want to minimize. Now we want to write this. This is still a lot of stuff to write, right? So we have what, 1, 2, for each, we have 2 terms, and we're doing this 6 times. So we're writing a lot already, 12 symbols. And that's only for a very small problem instance, which is 2 plants and 3 destinations. We don't want to do this when we have hundreds of plants and thousands of destinations. What we want to do is use the summation notation. So again, go back to that video and watch the video on summation notation, but simply this cost matrix can be, I say simply, but it's not that obvious at first, right? So it takes a bit of time. So this, all of this can be simply, when I say simply, it means like just kind of very little stuff to write, but it takes some thought, is written as such. We're taking the product, we're multiplying the unit shipment cost, CIJ, with the corresponding amount being shipped between I and J, right? But this unit shipment cost and this amount being shipped is between 6 origin and destination pairs in total, right? So how do we write 6 origin destination pairs? We use the summation sign, we iterate, we say that these destinations, we have 3 of them, and we need to iterate over all destinations. And don't forget the origins. We also have 2 origins, so we need to iterate over the 2 origins. So we need to multiply these 2 unit shipment cost and amount, but then add them up for all origin destination pairs. So the trick is to remember we have 2 indices here. So that means in the objective function, we need to add them up over both indices. If you have 4 indices, you're going to add them over all 4 indices. If you have 3 indices, you're going to sum them all over all the 3 indices. That's the only thing you need to pay attention. Don't forget to sum over every index that is showing up in your in the parameters and the decision variables. And that's true for the objective function only. Okay, we're just writing we're learning how to write the objective function. What I'm saying does not apply to constraints. We'll go over that separately. This is just minimizing transportation cost. Okay, so we did this in Excel, which maybe came to you more intuitively using the sum product function, right? So this is the matrix multiplication. The lazy way of doing this in Excel was just saying equals sum product, cost matrix, that's CIJ, comma, the decision variable matrix, which is the XIJ. So you just took 2 tables. You highlighted 2 tables in Excel. And that was how you did it. Again, this was illustrated in the matrix multiplication videos. If you don't recall how to do this in Excel, please go ahead and watch that video again. And that's it for the objective function. Next video, we'll talk about how to express everything in set and summation notation for constraints. But this is it for the objective function.